All right, let's get right into it. Today, we're talking about one of the biggest, most critical security threats facing AI right now. It's called prompt injection. And this is a vulnerability that really it strikes at the very core of how these models even work. So, think about that for a second. What if an AI's greatest strength was also its biggest weakness? I mean, that question right there, it really gets to the heart of this entire problem. Because the very thing that makes these incredible AI models so powerful, their ability to just follow instructions, is the exact same thing that makes them so uniquely vulnerable. And that's the strength, right? It's their whole purpose. We give them an order, a prompt, and boom, they follow it. They can summarize a massive document, write complex code, answer questions you'd need a PhD for, and they do it all because they are just masters at following directions. I mean, it's a brilliant design. But, and there's always a but, it's got a flaw. And yep, here's the weakness. See, to an LLM, an instruction is just an instruction. It doesn't have that human gut feeling, that intuition to tell the difference between a safe, totally legit command from a developer and a sneaky, malicious one hidden by an attacker. This is the hidden flaw we're going to crack open today. So, okay, how do the bad guys actually exploit this flaw? Well, they use a technique that we can think of really as a kind of digital heist. And their break-in tool of choice? It's called prompt injection. So what is it? Basically, an attacker injects their own malicious instructions right into the prompt. They're trying to trick the model, to get it to override its own safety rules and do something it was never, ever supposed to do. It's a total hijack. They're turning the AI's greatest strength, its amazing ability to follow instructions, right back against itself. So what are these digital thieves really after? I mean, what's at stake here? Well, the stakes are incredibly high. We're talking about stealing confidential data, generating all sorts of misinformation or harmful content, or even tricking the AI into spilling its own secrets, like its core system prompt. And you know what? It gets even worse when an AI is connected to other tools, because then an attacker could trigger actions in your CRM or a database, turning a simple data breach into a full-blown, real-world system compromise. Scary stuff. Now, these attackers, they don't just have one way to pull off this heist. There are two main paths they can take, and it is absolutely crucial to understand the difference. We can think of it like this. Are they going to bust through the front door, or are they going to sneak in through a hidden tunnel? Okay, let's break this down. Over on the left, you've got what we'll call the loud attack, or direct injection. This is the front door approach. The attacker literally just types something like, "Hey, ignore all your previous rules," right into the chat. It's obvious, it's explicit, and you're going to see it in the logs. But then, on the right, we have the silent attack. This is indirect injection. This is the hidden tunnel. And believe me, it is far more dangerous. Why? Because the malicious instructions aren't typed in directly. Nope, they're hidden inside some other piece of content the AI is just supposed to be, well, processing. And these hidden instructions, man, they can be anywhere. Just imagine an attacker slipping a command into the invisible text in the footer of a PDF resume they upload. Or maybe it's hidden in the source code of a web page you ask the AI to summarize. It could even be lurking inside your company's own internal wiki that your RAG system is using for information. The key thing is, the user, you'd never even see the attack, but the AI does. And this quote, this really just nails the core danger of these indirect attacks. It's the key takeaway right here. If the model can read it, then it can be manipulated by it. Let that sink in. Any data source your AI touches, any document, any website, anything is a potential attack vector. Okay, so if the threat is basically everywhere, how in the world do we defend against it? Well, the answer isn't some single magic bullet. It's about building a multi-layered security vault around your AI. And you really can't just rely on one single security measure and just hope for the best. That's kind of like putting a giant steel door on a tent. It just doesn't work. The only way to create a truly robust defense is with a strategy called defense in depth, where you have multiple layers all working together to protect the system. So this multi-layered vault of ours, it has 7 key components. First, you start with the fundamentals, right? You gotta patch all your models, and you have to deploy monitoring to watch for anything strange happening. Then we start adding more advanced defenses. Parameterization is huge. It strictly separates your system commands from the user's data so the AI can't get confused. Adversarial testing is basically like hiring your own team of ethical hackers to find the vulnerabilities before the real bad guys do.
And those last three, least privilege, input validation, and output validation. Man, these are so critical that we're going to zoom in on them right now.
All right, let's start with layer 4, the principle of least privilege. And honestly, this analogy just makes it so incredibly clear. Think about it. You would never give every single employee in your company the master key to the entire building, right? Of course not. You give them a key card that only opens the doors they actually need to go through. Well, the exact same principle applies to your AI.
Now, what's really important to understand here is why this is so vital. See, when an AI can connect to external tools, things like sending an email or updating a database, a prompt injection suddenly stops being just a text problem. It becomes a real-world risk. So by limiting what tools the AI can use for any given task, you contain what we call the blast radius. This layer is so smart because it works on the assumption that an attack will eventually get through. Its whole job is to limit the damage when that happens.
Okay, now for layers 6 and 7. Think of these as the security checkpoints at the vault's entrance and exit. Input validation is checking what comes in. It scans user prompts for suspicious phrases or hidden code before the AI ever gets a chance to see them. Then you have output validation, which checks what goes out. It inspects the AI's response before it's allowed to take an action, like calling a tool.
And this is just so critical. Most defenses, they only focus on the inputs, but that leaves this huge blind spot. The output is where the real damage actually happens. I mean, if you have an AI that's only supposed to be searching for information and suddenly it tries to delete a file, well, output validation should slam the brakes on that action immediately. It is your final, absolutely non-negotiable backstop.
So we've looked at the threat, we've looked at the layers of defense. What's the big takeaway here? What's the moral of this whole digital heist story? It really comes down to this. You are never going to be able to build a wall that is 100% impenetrable to every single prompt injection attack out there. It's just not realistic. The goal isn't perfection, it's resilience. The only truly effective strategy is to build a system with all these layers of defense, a system that assumes a breach will happen eventually and is designed from the ground up to contain it, log it, and minimize the impact.
So I'll just leave you with this final thought. These AI models are, without a doubt, some of the most powerful tools we have ever created. But with that great power comes a really great vulnerability. So the real question isn't whether you're using these incredible tools, it's whether you've built the vault you need to protect them.